Hi there, welcome back. Welcome to the third video in the restoration series for this Grundig Satellit 2100. And here I decided to tackle that which I was dreading most, which was the FM, which was very poor. And that worries me because FM is something that I'm particularly fond of. Most of these radios are useful, especially for FM, and this series has an incredible sound on FM. I know because I've done 3 of them. And I was sort of dreading this part, but if you stick around, you'll see that we had to get a bit creative, but we also got lucky. Enjoy the video. I've finally come to the point where I have to try the FM IF alignment because I've tried cleaning switches, I've tried all sorts of stuff. The FM is incredibly deaf. You can get some of the really strong stations through, but it's just not good enough. So I had to put the radio on its side. There's a sponge base on here so I don't damage that side. I've got it tied up with a string so it doesn't collapse. You don't want this thing falling right now. That would be a disaster. And this here is the FM board. So as you can see, there are 2 sections that are under shields. And we have the IF transformers here. There are 2 in here, 4, 6, 8, 9. So according to the service instructions, this is the end here. This is the discriminator one that you have to balance. Then you've got this one, and then those 2, and those 2, those 2. And what they tell you to do is to feed the signal progressively further back, exactly the same as we did with the AM alignment. So you make sure that you've got a transistor buffer between the injection point and the adjustment you're making. Now here's the funny bit. They tell you that there is a pad on the PCB which is capacitively coupled to the collector of that last transistor there. And I couldn't find it. I didn't want to remove this just yet. I don't know if I'm going to have to. I probably will, but we'll see. So I fitted a piece of wire in here, and I just sort of shifted in there, and I fed a signal in here, 10.7 megahertz signal in here. And I just sniffed around with the oscilloscope probe connected to that piece of insulated wire till I got a signal on the scope. So I know that I'm close enough for it to be capacitively coupled. It's not a very good connection. It's probably something you don't want to move around. That's why I've taped this down. But it does mean I can feed a signal here before, or rather on the section preceding the one that I'm going to adjust, and I'll be able to see the signal on the scope. Let me show you on the schematic first, and then I'll show you what's happening. So they tell you to just filter 9, you feed it to 0.3 of filter 8. That looks familiar, right? That's exactly what we did with the AM. And you monitor via an RF probe with the built-in diodes. That's also on the instructions. That's right here. So it's basically a demodulation probe where you've got a very small capacitor here, about 0.3 picofarads if I'm not mistaken. You've got a 100K resistor. You've got a, what is that? And it's an AA112. It's a germanium diode, another 100K resistor, and then it goes to the scope. I'm not doing it like that because I just want to make sure that I've got a signal on there. So again, we're back to here. You tune the one out. So B is out of tune, and A to maximum, C and D to maximum, E and F to maximum, GH to maximum, I, K to maximum, okay? Let's have a look at the schematics we're talking about. We are up here. So this is the section we're talking about. And what they want us to do is they want us to detune B, that's the discriminator one. So detune it so it doesn't affect that one. You want this thing to act as a tuned load for that transistor. And then what they want you to do is to feed the signal into here, and it goes through there. That's a capacitively coupled point over there. And then you adjust that for maximum when you are supposedly detecting at this point here, measuring point. Okay, you see that capacitively coupled thing there? So you put your probe on here, and you feed the signal in here, and basically this transistor does its business with this as a load, and what you get then is this thing gets tuned to 10.7 megahertz. All right, what are we going to do? Well, I can't get access to that point over there because it's on the underside of that, and I don't want to remove it just yet, but I can go a little bit further back, presuming this is not completely out of tune or open, and I can feed it to here where I know I can see resistor 510 on the board. So if I feed it into here, it's almost the same. I'm not trying to get optimal response values or anything like that. I just want to see the signal going through, because I believe my problem with the IF is a broken link here somewhere. The IF is getting lost. It's being produced because I know that some IF is coming through because this front end is tuning, and some of it's coming through because I can get the big station. So the oscillator is working. It must be, or I wouldn't be able to tune those stations. The problem is only very, very strong stations are getting through, and even then they're getting through pretty badly. So somewhere along this route, I believe we are losing the signal. So what I'm going to do, that little link that I made there with a little wire is basically this, except I'm not touching the board because the board has a little pad there. Here's the FM board, and they're telling us to detune A or B, I'm not sure. And you adjust the other one, and this is transistor 16, and you're supposed to feed it into 0.3 of the preceding coil, which is somewhere. Which one is it? Which one is it? 3 is this one here, isn't it? Yeah, this one here. Because that then comes across and it couples to the base or to the emitter. Is that the emitter? Yeah. Pin 3. So you feed it in there, gets it from there. Let's zoom in and I'll show you what I mean. Now this is not that easy to see, but here's the base of this transistor, okay? And the base of the transistor gets the signal from 5 over there. And that is correct because we can see the base of this transistor here, and it gets it from 5. But then 3 is the one that's capacitively coupling and going into the collector of that transistor. So here's 3, which is this one here, and you can see the shade here. This is the copper trace. This shadow here goes to there, and it sort of ends. And then it, boom, it takes on there again. It's sort of a broken line. This is a capacitively coupled signal. It's actually like a capacitor with 2 little plates and the air gap in between. And then that goes to the collector. And the collector carries on to here to resistor 514. But it's got this shadow here. This shadow here is that capacitively coupled test point to the collector of the transistor. So that makes sense. And I've fitted that wire through the hole, one of these holes here. I think it was through this one. And I fitted it in and just sort of pushed it into here so it can sort of sniff out the signal somewhere in the vicinity. And it works. I'll show you. But what I'm trying to do is I'm trying to adjust that one. And I'm feeding it into here. Except I can't reach this point. So I need to go one step back. And the way to go to one step back is to this resistor here, which is R510. And here's R510. And the one I want to feed it into, I want to feed it in as close as I can. So I'm going to feed it into here, the one that goes to connection point 2 of that filter. So R510 to connection point 2, it's this one here. So I'm going to feed the signal in here, and I'm going to monitor it over here. And what I'm sending in is a 10.7 megahertz signal. Now, mind you, it's going through these filters, which I'm not going to touch yet. I'm only going to adjust that one. But it should be good enough. And if that works, I can try and sort of optimize it, maximize it. I'm not worried too much about perfecting it right now. I just want to see where my signal is getting lost. Then I'm going to go one step back. And the way to go one step back is this guy over here. Okay? That's the equivalent resistor to the one we've just used. And if we look at this here, that was R510. If we go one step back to prior to this transistor, my suspicion is that the transistor's blown, I think. But I want to see which one of these. There are 4 of them over here. So then I feed it into this one. So I've fed it into 510. I'm going to feed it into 506. And then I can go back further and feed it into 503. And we'll see if we need to go back further, and we'll figure out where we're going to feed it in afterwards. Oh, that's going to be fun. If I have to go back here, it's going to be fun. Okay, but that's what I'm going to do. So we've got 510, 510, 506, 503, and it's always this bottom leg here that I'm going to use. So let me show you. I'll do that. We'll see the scope and see if we have the signal coming through. Oh, by the way, the amplitude of the signal, I don't know what it's going to be. So I'm going to start low. It's 10.7 megahertz signal. I'm going to start, say, at 5 millivolts or 10 millivolts, because this is right at the end. It hasn't had much amplification. As I go back, I've got to drop the amplitude because every one of these stages amplifies the signal further. But all I want to do is I want to see a nice 10.7 megahertz sine wave on the scope, and hopefully it's adjustable by me tweaking these guys. Okay, let me get on to it. Right, here we go. I've got the radio on. I don't need volume. This is not a volume issue. I've got the scope visible. I'm going to hit the, oh yeah, that's still there. I had it there a little while ago and I was worried that it might have disappeared. These things do happen. So I can see a 10.7 megahertz signal. It's sort of shifting around because I've got a lot of mains stuff on my bench here, so it's not as clean as I would like it to be. Okay, that's better. Now what I'm going to do is this is the one they tell you to detune. I detune it, I won't see it. Anyway, what I'm trying to do is make sure that it's there, and it is, and I'm going to play with this one. It's changing a little bit, so it's there. So that means that transistor in there is fine. Now I want to go back. I've got it on this resistor here. I'm going to go back one to that there. But I'm going to reduce the amplitude quite a lot. Let's go back. Disappeared, has it? No, it's the triggering that's wrong. Okay, it's there. Let's see if these guys have any effect. Oh, they do. And it was peaked. Whoa. Whoa. Okay, let me drop that. I'm dropping the amplitude on the signal generator. But that one's making a big difference. It had reached a peak. Okay, but I know that transistor is good. Okay. I'm going to go one step further back and I'm going to drop the amplitude again. Is that too low? Oh, what's happening here? That would be these guys here, right? I've lost it. I've lost it. Now that is going through there, through that transistor and those filters. Don't think there's anything wrong with the filters, so could it be that transistor? I wonder. Let me have a look at the schematic. What does the schematic tell us? So what did I do? I fed it in here and I got it going through. So that transistor is working, these filters are fine. Then I took it back from this resistor to that resistor, fed it through, and I could see it here, which means that transistor is fine and these filters are fine. And then I took it back to there and I don't get anything over there, so that means our transistor might be blown. How do I... Okay, they give us voltages here. That's interesting. Okay. At the emitter of this transistor, they say 2 volts. At the emitter of this transistor, they say 1.2 volts. And at the emitter of this transistor, 1.15. And the emitter of this transistor, 1.1. Okay, I can just check the voltages. I can't get into that one, but that's fine anyway, because that's inside the box. The emitters, which are the emitters? The emitters are that one, okay. It's the ones closest to us. Good. Let me go and test that. Let's see what we get. Okay, I think we can see everything. Let me see. What voltage do I have on here? 1.15. That seems to be about right. What do I get there? Nothing. and there. That's the collector. 1 volt. 1 volt, nothing. 1.15. That transistor is not passing any current because that voltage there is created by that resistor that goes from there to ground. So that guy seems to be blown. Let me check the voltage on the base. Oh dear, that's a bit strange. 0.8, 0.8. There's no base voltage. That is really weird. That is really weird, and it's not a short because there's 0.2 volts there. If it was a direct short. Let me check resistances. I'll switch everything off. Check resistances. What resistances do I expect? Let's have a quick look at the schematic. From the collectors, about 1.5K. From the emitters, about 1.5K. From the collectors, about, well, there's a 56 ohm. I'm just measuring, adding resistors up. From the base, what is the base? The base is 1 coil and a 3.3K. That base should have 3.3K plus 8K, about 11K to ground. We see that base has less. That's about right, according to the schematic. That one? Oh dear. Oh no. No, 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 no. No. 7 meg. Oh, that coil is open. Oy vey. Let me show you on the schematic what I've just done. Here I've got the base goes to there, through that coil there, which is between 4 and 5. And then it goes to here, that's a capacitor. I'm measuring DC resistance. Then I get 3.3K plus 8.2K to ground. So I should get about 11.5K to ground, and I'm getting 7 meg. So that connection from here to ground is not working. Yeah, that is open. I'm going to just check this resistor, this one here. I pray it's the resistor. Let me just check that. If it's not this resistor, it's that coil. That's not good. Not good at all. But let me just check the resistor. It's we're talking about resistor 508. 508, was that the one? Or is it 504? No, 12. It's 504. Sorry, this one. 3.3K plus 8.2. So yeah, 11K from the base to the resistor is what I'm trying to measure, and then from the resistor to ground. See where the break is. So resistor 504. That's the one side. 13K. 8.2 plus 3. Oh, that's not good news. So the break is between the base of the transistor, through the coil, and then to the resistor. Something's broken over here, and it certainly looks like it could be this guy over here. That is not good. How can I check? I tell you what I can do. I know what I can do. I know what I can do. I could bypass that. I need to take this board out and see if this is not something on the underside of the board, maybe a cold solder joint, a cracked solder joint. I really hope it is, because I don't know where I'm going to get one of these from. You could always bypass that section You get a little bit less gain, but that should work. The transistor seems to be, probably is okay. Okay, I found the problem. I have found the problem. And I know how I'm going to test if that's the problem. Let me show you. Okay, this is what I'm going to try. I'm going to try and bypass that stage. And the way I'm going to do this, I think you can just hear that. I've got it at maximum volume. You can just hear a station there. Let me see if I can find a stronger one. You can just hear it, okay? I'm going to try and bypass that. And the way to do that is to go from this resistor here, bypass it to that one. Yes. There's a lot of distortion because this thing's untuned here. Okay, brilliant. Okay. All right, I'm happier now. I'm happier now. I'll tell you why I'm happier now. I'm happier now because I know there's a solution. So what have we found? If we bypass, let me switch this off. If we bypass that section there, which includes those filters, okay, we get audio, we get the IF frequency going through. I was taking it off from that resistor there, which is the one where I was injecting when I was trying to test this. So we're taking it from there and we're bypassing it completely to the equivalent resistor just before the next stage. And we have got our IF going through. As I said, it's missing one gain stage and one filter stage, but at least I know that the problem is here. And I don't think it's the transistor because I've got no continuity from the base of the transistor to ground, and there must be continuity, and it goes through the secondary of that coil over there, which I'm hoping is not blown. But I have fixed one of these in the past. I took it out. You can actually take it out, and I found the little wire was just desoldered, well, broken, and I managed to fix it. Alternatively, I may have a solution. I may be able to find one of these, but we'll see how we get along. I think my next step is to remove this. I've got to remove this whole thing. I've got to try and make sure I don't unwind all that and get in there. And hopefully it's a broken solder joint. Hey, I've seen weirder things than that. I'll get back to you as soon as I've got something to report. Well, do we have progress or do we have progress? I'll let you guess. This thing's come out, as you can see, and I've got quite a bit to report. The first thing I had to do was to remove that board from the base of the radio. And in order to do that, I removed the tuning dial from the tuning condenser. I first turned it all completely counterclockwise so I know how it's going to go in. And then I used a lot of press stick. I use it to hold all the string in place and also this the dial itself, so I don't have to rewind it. That's always a good thing. And it just slips out and you put it aside and you're safe for now. Then there are two screws at the top here, which you take out. And that, I think, is it. Then this whole thing just sort of slips forward and up because it actually slips into a groove at the back there. It doesn't have any screws at the bottom. So that's quite easy. And then there are a few things to desolder. The first thing, or the first two wires were these two over here. I didn't really need to desolder them. I found out later because this thing actually sort of slips sideways or around, but I did anyway. And I did the same for these two, just desolder them. You'll see why they're back in a second. Now, once that comes out, you leave that main umbilical cord over there. Leave it well enough alone. You don't need to take it out. But once this comes out, you can then get on the underside and you can then desolder the component you want to. And as you're aware, I was right. This is the guy that had an open coil. The secondary on this little bugger, the one that feeds the base of that transistor in the, this is an IF transformer, this is the IF amplifier, one IF amplifier transistor, that coil was open. Everything else is making good continuity to and from those points. There are no broken solder tracks, so it was this guy. And I removed it. It's fairly easy to remove. You've got about 5, 6, 7 connections, desolder them. I use solder braid, make sure they come out neatly and without any damage to the actual transformer. And once that's out, I then was able to have a closer look at it. Once you have this thing out, it's actually quite easy to pull it open. There are no clips on the bottom of these. Sometimes they have these little metal clips that you have to bend out. This one didn't have that. No strength required. It's just very, very simple. And then you unscrew the top cap. That cap is actually the ferrite element that slips in and out and changes the coupling and the inductance of the coils. You slip that out and then you can see the coils. Now, one of the coils is the primary, and that primary has, I call it a primary, it's got that capacitor across it, the 100 picofarad capacitor. That capacitor's on the underside, and unfortunately, I should have taken more photographs of this. The other side had one of the wires actually broke off. It was going into the coil, it was forming the coil, the turn, but as I touched it, it just broke off, and I could not see that connection at all. There was no way I could repair it, so I had to ponder what to do. And I decided to do what I've done before, and that is I removed the remaining wires from that coil, and I actually wound another one around it. And the problem was I didn't know how many turns it was. It looks like one turn, but I couldn't be sure because it's actually underneath or below the primary. The primary, you can actually count the turns if you had to, but this one you couldn't at all. And it's not to do with the wax or anything like that. It's just that it is sort of inside a groove that's on the former, and I couldn't count it, but I thought it was one turn, but I decided to give it 2 turns just in case. And of course, I then soldered it to the legs, and I put the whole thing back and fitted it into the radio. And you can't see any different. There is no difference. This is the original transformer. But I had no idea whether this thing was going to work or not. Whether I could tune it, whether it would make a big dent in the bell curve for the IF chain, I had no idea whatsoever. There was one other solution that I could have used, and that is you can actually bypass this, not the way I did it, but you can bypass it by putting a resistor from that base of that transistor to ground, or not to ground, but across that coil. So you put a resistor across that coil to bias that, and then you actually feed the signal from the output of the previous section, in other words, from the other side or this side of this resistor, as we saw earlier, not the end, but the beginning. You feed it with a capacitor to the base, straight to the base. And that means that one side of that, one part of that can still be tuned. But you do reduce the sharpness of, or the possibility of sharpening the curve, but you do get your signal going through. And I tried that, I actually tried that. And the capacitor is very small. It's about 10 picofarads, and it's before the resistor, so it's actually shifted away from the tank circuit that you are tuning as the load of the previous transistor, so it doesn't really affect it too much, and you can get the signal across. But I wanted to do it without any of that in there. I wanted to get this thing back and working. Obviously, the third alternative was to find one of these transformers. Good luck with that. So I then had everything in place, and as you can see, I've gone one step further. What I've got set up here is I've got everything set up for an alignment. And this is by the book, exactly as per the instructions. What they tell you to do is they tell you to put a detector with that diode, you know, the germanium diode. And that's exactly what we have here. It's just got a BNC connector, so it goes straight to the scope. Having access to the back also lets you solder a little wire to that hole there. There's a patch there. That's that island of PCB, which is the capacitive coupling to the collector of that transistor they mentioned. And I've got a little wire coming out, and I've got the tip of that probe soldered to that. So we've got our detected signal coming out and going to the scope, channel 1 of the scope, okay? What we've got then is the signal generator sending a sweep. It's centered at 10.7 megahertz. It's a span of 400 kilohertz. It could be more, could be less. That's what I choose. And that trigger from that is going to channel 2 of the scope. And this is what we have right now. I've got channel 1 is from that detector diode setup. Channel 2 is the trigger from the signal generator. And as you can see, that's 2 periods of the waveform, and that is 1. So I've got it on 10 milliseconds per division, so I've got the sweep time at 140 milliseconds. Now let's look at the scope, and I'll show you where I'm feeding the signal in. You see, what I've actually done is I've actually aligned it, and it took me quite a while, so I'm not going to redo it, but I'll show you the result. And the way to do this, the final step of those instructions, is they say that you couple it lightly to the beginning, the first filter. And I found that if I've got this insulated, there's no contact. If I push it in here, there's a point where it'll stick, and you can see the scope. That's our curve. That is our entire curve. And the only one I'm not messing with is the one inside here, because it's a different end, and I don't want to mess it up. But I have full control of this, and I've got to be careful because I don't want to mess it up completely, but I'll show you the result. Now remember, the middle of that of the screen is exactly 10.7, okay? This is the one we messed with. It's a little bit tight, so I'm not going to push it. Right in the center. When you spend a lot of time setting this up, it's fine to do what I'm doing, which is just to tweak it a bit and show the results or show the effect, but you certainly don't want to mess it up completely. When you've got this thing completely messed up, remember I'd been twiddling with these things, it takes a while. It takes quite a while. But I'm happy with the result there. Now, I've got this thing going through all the way, including this one here. Now, the last one, which is this one, this is the one you need to adjust to balance the discriminator. And the way to do that, they tell you what to do. I'm going to do it differently. What I've done now is I've sent a signal, a modulated signal, 10.7 megahertz, but it's got a tone on it, a 1 kilohertz tone. And I have passed through the speaker. I've got the speaker on dummy load, but if I put it on, you can hear it, okay? Put it on dummy so we don't hear it, but we can see it on the scope. And as you can see, I can adjust it with the volume control. Now what I'm going to do is I'm going to tune this one that we have to tune, and I'm going to tune it till I get the best sine wave. B is this guy over here, and I'm going to tune it till I get the best sine wave possible. Remember, I detuned this, so watch that. You can see that. Whoa! We lower the volume. It was completely untuned. I'm lowering the volume again. There's our peak. Goes down, up and down. That is, in my opinion, by my method, perfectly aligned. The other thing I can do is I can change the modulation to AM modulation. You see it's gone all the way down, but let me put the volume up. That is AM modulation. Now what you want to do is adjust this to get the best AM rejection. And it was there. There. Okay? That is the best AM rejection. That's the best sine wave we can get, I think. Practically there. That's it. So what exactly have we achieved? Have we got FM back? The more observant of you, if you look at that, that's the strength meter, tuning meter. You'll know we do. I'll put the volume up.
Variadíssimos fatores, mas o desemprego é grave, torna-se muito grave porque
love it.
falta de...
O ocorrida amanhã às 8 na Gulbenkian, no recital esgotado, como seria de esperar.
So we've got our FM back, and it's actually tuning quite accurately.
Uma operação policial em
That's at 101.6.
Dois dos acusados que no continente adquiriram e transportavam droga para a Madeira foram condenados a 4 anos de prisão. Na região, os outros 3 elementos, 2 homens e uma mulher, foram condenados hoje pelo tribunal.
Now, the AFC is working as well. Watch this. It's on AFC now.
Um dos elementos estava já em prisão preventiva, os outros estavam com pulseira eletrónica.
See that?
Devem dar entrada na cadeia assim que a sentença transitar em julgado.
AFC, I can tune just to the edge and it latches.
Que apresentem reformas e mudanças. O líder do PT ainda não falou com Luís Montenegro ou Jorge Pereira da Silva, os candidatos à liderança do partido, mas já vai avisar que é necessário apresentar um programa de mudanças. O PSD não pode ser um partido conservador para manter tudo.
I am so happy. I am so happy because I was really worried about the FM. And when I noticed that the IF transformer was a problem, you know, that is a problem. That can be a serious problem. It can be a project stopper until you get a replacement. And judging from my previous requests for help, you guys have been amazing. I've always got replacements, but this one was achieved without having to wait. I got to rewind that transformer, which is something I wanted to try again, and it worked well. And the tuning, the actual IF tune, the IF tuning band looks really good. The quality is good. We've got some good quality audio, so I'm truly happy with this result. Now, I'm not sure exactly how I'm going to progress from here. There's quite a bit of RF alignment to do. I need to do some cleaning. In the meantime, I'll think about it, get some more done, and report back as soon as I've got something to show you. I want to thank you all for your company. Hope you've enjoyed that. If you have, click like, share, subscribe, and all that jazz. And if you want to support the channel directly, you can do so on Patreon. Once again, thanks for watching. Bye for now and stay safe.